Welcome to qnawire.
So they're asking us if we send a pulse through both of the wires, what's the time delay through both of the wires? So let's do the weight of the beam, 750 newtons. Of course, let's just write our givens. And then we have two vertical wires, A and B. And then each of them have a length of 1.25 meters. So they both have a length of 1.25 meters, and they both weigh both weigh. Well, actually, let's just say that if capital W is the weight of the beam, we can say that lowercase w is going to simply just be the weight of the wires, so 0.290 newtons. And then at this point, we can say, okay, the center of gravity, so center of gravity is 1/3 of the way along the beam from A. So from A, which is at the end. So from the end of the beam, so the end of the beam is, there's a wire connected to the end of the beam, wire A. And then from that beam, 1/3 of the way along the beam, from that end, rather, sorry, 1/3 of the way along the beam from that end, there is the center of gravity. So here we have to use, we can sum the moments. So we can actually take the sum of the moments about one end so that we can find the tension at the other end. And we can say that the sum of the moments about end A will take clockwise to be positive. So this is going to equal 0 because, of course, this beam is stationary. We hope that the two wires are supporting this beam. And this is going to be equal to the weight of the beam times the length of the beam over 3, because the center of gravity is, again, 1/3 of the way from the end, or point A. Plus, and then we'll define a new variable, the tension in wire B times the full length. So the other end of the beam has a wire connected to it, wire B. And then at this point, we can say, okay, let's relate and say that the tension BL, tension in the wire B times the full length of the wire, equals the weight of the wire times the length divided by 3. The tension in the wire B is going to equal the weight of the beam over 3, 1,750 newtons divided by 3. The tension in the beam is going to be 583.33 newtons. Now, at this point, we can say, okay, let's take the sum of forces in the y direction. This is going to equal, of course, 0, acceleration in the y direction. So this is going to be equal 0 because the beam is not moving up or down, of course. So this is going to be the tension in A plus the tension in B minus the weight of the wire should equal 0 newtons. Or we can say that the tension in A is going to be equal to the weight of the beam minus the tension in wire B. 1750 newtons minus 583.33 newtons, and this is going to be 1,166.67 newtons. Rather, 67 newtons. At this point, we can say, okay, the linear density of the, let's put our knowns over on the top right. The linear density is going to be equal to the mass over the length. And we know that the weight is equal to mg, which means that the mass is going to be equal to lowercase w over g. Again, we're trying to find the linear density of the wire. So we now have an equation. We know that V is going to be equal to the force tension over mu, and we're trying to find the delay. Remember, we're trying to find the delay. So of all these variables, don't get lost as to what we're trying to find. So we're trying to find the delay. We found a propagation. The equation for propagation speed is the square root of the force tension divided by mu. So we can say that the velocity is going to be equal to FL over m, plugging in this equation right here in for mu, and then we're going to further define this and say that the mass is going to be equal to FL. The mass is going to be equal to the weight over gravity. So if we're dividing by mass, we have the force times the length of the wire times the acceleration due to gravity all over lowercase w, the weight of that wire. And now we need to find the velocity in wire A. This is going to be equal to the force, so 1,166.66 newtons, and then 1.25 meters is the length of the wire, and then the acceleration due to gravity, 9.8 meters per second, all divided by the weight of the wire, 0.290 newtons. This is going to give us a velocity of 222 meters per second, approximately. The velocity in the wire B is going to be 583.33 newtons times the length of the wire. Both of these wires have the same length and the same weight. The acceleration due to gravity, all divided by 0.290 newtons. This is going to be equal to 157 meters per second. The delay is going to be equal to the length divided by the velocity. So however long the wire is divided by the slower wire, the velocity of the slower wire, minus the length of the wire divided by the velocity of the faster wire. And then we can say that this is going to be equal to 1.25 times 1 over 157 minus 1 over 222. And we find that this delay is going to be equal to 0.00233 seconds, or we can say 2.33 milliseconds. So this will be the delay if we sent a pulse through each of the wires at the same time. The pulse would reach the top of wire A 2.33 milliseconds faster than the pulse would reach the top of the wire B. And that's the end of the solution. Thank you for watching.